Hi everyone, here is ChongzhiXu from Team 9 with our final project named CityBeam. A work that integrates technology and practicality, was designed for garbage sorting and new smart city services. So now please let me introduce the basic information about CityBeam. The hardware assembly and the software connection is shown in these two pictures. It has two main working iterations, dropping the trash and server map updating. Please let me introduce my two teammates, HanshanLi and YinsenJia, to give a brief introduction to these two iterations. Here is the first working iteration presented by HanshanLi.
Okay, at first, we're gonna put plastic trash in front of our Raspberry Pi camera. It is supposed to recognize it in several seconds, and then it will automatically rotate to plastic section of our city bin. Yeah, it's circling, and you can also see the prediction on the screen, plastic detected, and then we have 8 seconds to let the camera recognize a metal can, and it is supposed to rotate. Yeah, it is rotating. And you can see on the screen metal detected. We put the can inside, and finally we let it recognize paper trash, and it is supposed successfully rotates to paper section. Paper detected. Put it inside, and that's it. If no more trash, the trash can lid automatically rotates back to device part. Yeah, device part here, and it will implement the precise position reset, and then it begins volume detection. You can see on the screen shows it is detecting. Uh, Volume is realized by leveraging a distance sensor here. It will add up all the distance detected and take an average as volume indicator. Volume data is then uploaded to server, and server will return a new binding of the trash tabs. Okay, you can see it's rotating back to its device part and doing the precise uh, position reset again. And it shows other part of the trash can so that users can throw other kinds of trash inside this part. Okay, enough for garbage recognition and volume detection. Next, we will imitate a worker, takes out all the trash. Underneath the city bin lid, we can see there is a Lego design of the connection between lid and motor, so that it's convenient for the worker to open up the lid and takes out all the trash, and also convenient for the worker to put it back and carefully settle it down. Okay, after the dynamic volume adjustment in the first round, let's try it again. In the second round, we will still start with plastic trash. We will put it in front of the camera, and let's see the result. Okay, so the system still binds this section to plastic trash. Plastic detected, we throw it in. Okay, how about the paper trash? Okay, on the screen we can see it's recognizing. And now system binds the largest section to paper trash because according to the volume detection in the first round, paper trash section is where the most garbage is collected. And yeah, so that's it.
Okay, now let's see the second working iteration.
We also have a server for all bins trash detection. This is extremely convenient since there's no need for us to set each bin for detection. Apart from that, our city bin will collect all data to upload on our server and generate a map for government or company to better assign each bin. As shown in this map, the location of each bin has been marked as green garbage can logo, apart from one real bin, which shows in yellow, and one simulation bin located in our school. All bins could show their location and ID information by using API. If we click it, it can also show the history information about garbage volume for each classes. As shown in this real bin, we put metal, plastic, paper, trash last time, and the paper is the highest one, which occupies about more than 40%. And we reset it to take out all trash, so it decreases to 0. At iteration 2, we put plastic and paper, so both sections have detected some volume, but for other, there's no trash. The axis shows our time information about this process. Meanwhile, our server will show an area to represent this area's most kind of trash based on history data. Like here, now it's mainly paper. We could also click them to see current volume, represents in each section from A to D. Because we have reset this bin, there's no current volume now. For simulation, we have manually generated some data in our simulation bin, which is located here. You could see that the trash volume increases by time, and the most kind of trash is metal. So the circle is black circle, and the most garbage is metal here. If any classes of volume is larger than 50%, the bin would change the red color to remind people collect garbage and reset them. You could also check current volume by clicking the circle area. By using our server history knowledge about garbage volume, our city bin will assign new trash type for each part of our bin in next after reset. This dynamic adjusting function is to make our city bin more intelligent and assign each part more reasonable.
Okay, thank you everyone. Here is our project demo and hope you enjoy.